Students, today we will understand the first lab program, how to implement Bressenham's line drawing algorithm for all types of slopes. Considering the slope value m greater than 0, less than 0 or m is equal to 0. So we'll implement the program to draw a line segment by applying the concept of Bressenham's algorithm, which is based on the midpoint line concept. So we'll see how the Bressenham's algorithm is implemented in the program. In the program, we'll include the required header files. Variables like x1, y1, x2, y2 are the endpoints of the line segment x1, y1, x2, y2 or of type GL int. In the main program, printf Bressenham's line drawing algorithm, it reads the user input for the endpoints of the line segment, what is x1, y1, that is x1, y1, and also reads the other point of the endpoint of the line segment, x2, y2. Glut init initialize the glut library. Glut init display mode will set the mode indicating the type of buffer as glut underscore single indicates single buffer, and also RGB as the color mode. Glut init window size specifies the size of the window 400 cross 400. Glut init window position, we have specified a position 200 comma 200. Glut create window creates a window and the name of the window is Bressenham's line drawing algorithm. So in the main function, we'll call the init function. In the init function, GL clear color will set the background color of the window. So you can see the background color is set for green. GL matrix mode to set the mode to the projection mode. GL load identity will load the identity matrix by default. Glue ortho 2D specify the clipping plane, the x-min, y-min coordinates and the x-max, y-max coordinate. The glue ortho 2D, a function which specifies the 2D viewing clip plane size. In the main function, registered callback function is display. Glut display function is the registered function and the name of the callback function is display. So what to be displayed on the window created? So from the main function, I will call the display function. In the display function, GL clear will clear the color buffer. The variable called M is of type GL float. M here indicates the slope variable. So first we will compute what is M, the slope for a given line segment. So M is equal to y2 minus y1 and x2 minus x1. So first we are going to read the user input for the endpoints of the line segment. So according to the user input, say for example, the user input x1, y1 is 200 comma 300 and x2, y2, the user input x value is 400 and y value is 450. So for this given endpoint line coordinates, if we compute M, say for example, M is computed as per the given example and M is equal to 0.75. So the M value is less than 1 in this case, according to the user input. So once we compute M, next in the if statement, we check for the condition whether the slope value M is greater than or equal to 1. So if the condition is true, then we call a function line Bressenham function by passing the parameter that is the endpoint of the line segment x1, y1, x2, y2. Else, if the condition fails, if the condition is not true, we call the else part that other line Bressenham function by passing the same parameter endpoint of the line coordinates. So if I go according to this example of the user input, the slope value M is less than 1. So here the condition is false, where the slope value is 0.75, which is less than 1. So since the condition is false, we'll call the function line Bressenham underscore L1. This is line Bressenham underscore L1 function. The parameter passed is the two endpoints of the line segment along with the float value. In the Bressingham function, first we calculate what is dx. Dx is xn minus x0, dy is yn minus y0. So according to our example, it is nothing but we are just finding the subtraction of the x coordinate and the y coordinate respective start in x coordinate and the difference between the start and respective y coordinate. Then we will calculate what is the incremental factor P, which is P is equal to 2 into dy minus dx. Then 2 dy is equal to 2 into dy. Then 2 dy minus dx is being initialized with the equation 2 into dy minus dx. And let us consider initially x is equal to the start xy coordinate x0, y0. So I have initialized the starting xy coordinate value for the variable x and y. So according to the given user input, say for example, x0 is 200, x0 is 200 and y0 is equal to 300 and x end is 400 and y end is 400. So we know the start coordinate of the line segment and end coordinate of the line segment. I can calculate the next step. What is the slope, which is 0.75. We have already computed. So we know the value of 0.75, which is passed as a parameter to this function. So we will compute what is dx. So if I calculate dx will be 200, dy is equal to 150. And then let's compute what is the incremental factor P, that is 100. Let's calculate what is 2 dy, that is 300. 2 dy minus dx is 100. So once all this computation is done, let's initialize what is the starting point of the line segment, which is x and y. Now I have to determine which point to use as a start position. So I have to check whether my start coordinate value, xy coordinate value, is it greater than the end coordinate value. So we check that by using the if statement. Whether x0 is greater than xn. If start x coordinate is greater than end coordinate. So if the condition is true, then we need to swap the contents. Then x should be now initialized with the value xn and y should be initialized with the value yn, and your xn will be equal to x0. Else, if this condition fails, then x will remain as x0 and y will remain as y0 as per the initialization. So once we find what is the initial coordinate of the line segment, so we just call the function set pixel, so to plot a point at that particular xy coordinate position. So this is the function set pixel. Set pixel, GL, color. So what is the color which I set for that pixel is a red color. And the pixel is where I place a point on that particular position by calling the primitive GL underscore point as a primitive to GL begin. GL vertex will draw that GL vertex takes upon the two parameter value x coordinate and y coordinate. So set pixel will just plot a point at the xy coordinate position. So once a pixel, the starting end point of the line segment is plotted, next using a while loop, I check now the x value, is it less than xn? Okay, if the x value is still less than xn, if the condition is true, inside the while loop, I just will increment the x value. If P value obtained is less than 0. If it is less than 0, then we need to calculate what is a new incremental value, which is equal to P equals P plus 2 dy. Hence, if the P value of this condition is false, then we have to check for again what is the slope value. Is slope m less than 0, then compute the y value, which is the decrement count by 1. Okay, y you will decrement by 1, or else increment the y, and also you are going to find out what is the new incremental p value, which is equal to p plus 2 dy minus dx. So once we find out what is the new y value, p value for the x, we can again call the set pixel to plot a point at that particular pixel value. So this loops will run until all the intermediate coordinate points between the start and the end points is obtained for a line segment. So in the display function, based on the slope value, we have two defined user-defined function, line Bresagnam function. So what I discussed was now for the case when m is equal to less than 1, where since according to the user input, suppose it is 0.75, m value less than 1. Similarly, if the slope value is greater than or equal to 1, we have the same line Bresagnam's function, which is here implemented for the case when the slope value is equal to greater than or equal to 1. So here you could find the difference like only where the x coordinates I have been replaced with the y coordinate. So in the function, I again will compute what is dx, dy, p, 2dy minus dx, and initialize what is the start coordinate, start xy coordinate of the line segment. Now I check whether the y0 is greater than yn to just check whether the starting end point, that is start y coordinate value, is it greater than the end. If it is greater, then we need to swap, or else your xy value will remain the same. Then set pixel, we call the function set pixel to plot a point at that particular position. Now in the while loop, we check for the condition whether the current y coordinate value is less than yn. If the condition is true, then I increment y by 1 unit and check for the condition of incremental value p. If p value is it less than 0. If the condition is true, then I will find out the new incremental value p, which is equal to p plus 2 dx. Else, again check whether the slope value is less than 0, decrement x. Or else, if the slope value is greater than 0, then you have to increment x as well as find out what is the new incremental p, and then plot a pixel at that particular position. So this while loop runs for all the coordinates from y min to yn, that is y start to yn, unless the condition becomes false. So in the end of the main function, we have the glut main loop will start the event processing, and this completes with the program, and the program output when you compile and run will ask for the user to enter the starting end point of the line segment and the start and the end point vertex coordinate of the line segment. So based on the user input, you can see a line segment is drawn. You can also find a very small pixel observed here, that is, which gives a jagged appearance of a line segment. Thank you.